Review of linear relations. Sorry, I might cover up half of this so you're not staring at a whole screen full of stuff. Okay, so linear relations, as we've mentioned before, are connections between two variables, our x variable and our y variable. The example I used in class the other day was this is my age, and this is the age of the youngest I can date. It could be this is the amount of days without rain, and this is the decreasing volume in my water tank. It could be the amount of petrol I am putting into my tank and the price of what I will pay at the end. All these pairs of things are related, and they're related linearly, which means that the set of pairs of the relationship, when you graph them on the Cartesian plane, form a straight line. So that's what I mean by linear relations. The relationship when graphed is a straight line. So this is our old friend, the number plane or Cartesian plane. It's made of crossed number lines, crossed at 0. We have the x-axis and the y-axis, and I'll talk a little bit about a review of Year 8 as we go through. The first thing we need to remember is how to graph these straight lines. Any straight line has a rule that links whatever the x variable is to the y variable. We often talk about the x variable being the explanatory variable and the y variable being the response variable. This is basically a rule. If we know x, we can find out y. Or if we find whole bunches of different values of x, we can find out all the different matching values of y, and that will make a straight line graph. I need to make sure you know what this little thing means. It's not as scary as it looks. This is saying, if you look at it mathematically, -3 is less than or equal to x, and x is less than or equal to 3. All it's saying is that we want you to use values of x between -3 and 3. So they're saying graph this relationship from -3 to 3 on the x-axis. When we do a table of values, x on the top, y on the bottom, put our options of values for x in here, and we're going to substitute each value of x in and work out its value of y. So -2 times x is -3, -2 times -3, +6, 6 plus 2 is 8. -2 times -2, 4, 4 plus 2 is 6. -2 times -1, 2, 2 plus 2 is 4. 0, because -2 times 0 is 0, plus 2. And you'll have noticed, of course, and you'll remember from Year 8, that we've got a pattern here. And in fact, we could just follow this pattern down because we're taking away 2 each time. And you might also remember from Year 8 that the pattern, the change in y as x goes across by 1, is the gradient. It's the coefficient of x. For every 1x, I'm dropping down 2 on the y. This is our gradient. We'll talk more about the gradient later, but we've already learned how to find the slope of a line, the gradient, and that's where it is in the rule. So once we've got a table of values, you'll remember, of course, that these make sets of ordered pairs, x and y, and we need to be able to graph them. So if you're asked to graph a line, it means properly marking up the gradations, the little lines, evenly spaced and evenly numbered on your number plane. Remember that those must be on the grid lines, and while these have to be the same spacing and value, and these have to be the same spacing and value, the two axes don't have to match. So I'm going to make each gradation here be worth 2, but each gradation on the x-axis is worth 1. Oops, ran out of space. 8. Labelled my axes. When you're asked to graph a line, you plot your points. -3, 8. Plot your points. Join them with a straight line. Now technically, because they said only do this when x is -3 to 3, technically you would say actually this is a line segment. It's not a continuing line with arrows because they said I only want this bit. If they didn't say, I only want this bit, you would have to continue this past the points and put arrows, and I won't hassle you if you always continue it past the points and put arrows. But technically, because they said limit it to this, we should limit it to just that range. And label your rule y equals -2x plus 2. So that's a review of graphing lines. It's different to sketching a line, which we'll learn about later. A quick review of intercepts, the x-intercept and the y-intercept. Intercepts are just where the line cuts through or intercepts with the axes. So the x-intercept is where the line cuts through the x-axis, and it will always be the value of x when y is 0, because y is 0 at this point all along the x-axis, y equals 0. So where y is 0 is where the line is touching the x, or cutting through the x-axis. X-intercept, value of x when y equals 0. Give your intercepts as coordinates, please, not just as x equals 1. Your intercept is the point 1, 0 for this. You can also get it from the table of values, the value of x when y equals 0. Here is our x-intercept. We'll learn how to substitute the value in. For the moment, we're just reading it from our table of values or the graph. The y-intercept is the value of y when x equals 0. So here, our y-intercept is at y equals 2, and you'd give that as 0, 2. Notice that that's the same as our constant at the end of this rule, and that is in fact always going to be our y-intercept, because when x is 0, this part of the rule cancels out and I'm left with just that. And of course you can get your y-intercept from where x is 0 on the table of values as well. Please do give them as coordinates. The forms of linear equations. We'll learn more about why this is called the gradient intercept form. I suspect you've already worked it out. It's when your line looks like y equals, and you have a number in front of the x, the coefficient of x, plus or minus a constant known as c, or sometimes it's written as y equals mx plus b. I will accept either. And that's this sort of rule here. Y equals something in front of the x plus or minus something. It's called the gradient intercept form because the coefficient of x is the gradient, and the number on its own, the constant, c or b, is the y-intercept. So if a relationship looks like this, y equals, it's in gradient intercept form. The general form of a line is when we rearrange this to have everything on one side, and often that will require some changing around of what the numbers are, which we'll see shortly. And that's ax plus by plus c equals 0. Or sometimes they leave the constant on the other side and we get ax plus by, and they use d for when you leave the constant on the other side. Different books will use different letters at times. It does get a little bit annoying and confusing. So we do need to be able to rearrange a line that is in general form into the form of y equals mx plus b, or vice versa. And really that actually means solving an equation for y. I need to get this to be y equals. So it's a case of saying, I had y, I multiplied it by 2, then I added 4x, and I got 10. I need to reverse that, do reverse order of operations just to get y on its own. Take away 4x from both sides, so I'm left with 2y equals. Now because we want the x at the front of the line, ideally, we'd probably say negative 4x plus 10. And then I had y times 2. I need to divide by 2. You must remember to divide both terms, or all three terms in this equation here, by 2. 2y divided by 2 is y. Negative 4x divided by 2 is negative 2x. Plus 10 divided by 2 is 5. So I've rearranged that into the form y equals mx plus b. And we can rearrange out of gradient intercept form into general form. Here I just want everything on one side except the constant. So the only thing I need to remove here is this 4x. And I'll subtract 4x from both sides. You see, I do want the x first. So again, I'd probably write negative 4x plus y equals negative 7. You could absolutely leave it as y minus 4x equals negative 7. It wouldn't really matter either way, and this is probably a little more obvious to you.